Welcome back to Geology Dean's mini-series on igneous rocks. In this episode, we're connecting everything we've learned so far to the grandest theory in geology, plate tectonics. Episode 10 is all about how igneous rocks are a direct result of the incredible forces that shape our planet. Let's dive in. Plate tectonics is the engine that drives a huge amount of the rock cycle, especially the formation of igneous rocks. Think of it this way. Different tectonic settings are like different kitchens, each cooking up its own unique type of igneous rock. The rocks themselves become a geological record, telling us what kind of tectonic activity was happening, when, and where they formed. So, let's explore some of these major tectonic environments and the signature rocks they produce. First, let's head to the mid-ocean ridges. These are massive underwater mountain ranges where new oceanic crust is born. As tectonic plates pull apart, hot mantle material rises to fill the gap. This material undergoes decompression melting, creating a massive amount of magma. What kind of magma? Basaltic magma. This mafic lava erupts onto the seafloor, creating pillow basalts, and also solidifies beneath the surface as gabbro in magma chambers. So, when you think of mid-ocean ridges, the rock that should immediately come to mind is basalt. It's the single most common rock on the surface of the Earth, forming the foundation of all our ocean basins. Now, let's move to a completely different and much more dramatic setting, a subduction zone. This is where one tectonic plate, usually an oceanic plate, dives beneath another plate, which could be continental or another oceanic plate. As the subducting plate sinks, water trapped in its minerals gets squeezed out. This water rises into the overlying hot mantle wedge, lowering its melting point and causing it to melt. This process, called flux melting, creates magma that is typically intermediate in composition. This magma is stickier and more gas-rich than basaltic magma, leading to explosive volcanic eruptions. The signature rock of subduction zones? Andesite, named after the Andes Mountains, a classic example of a volcanic arc formed by subduction. So, volcanic arcs, both on continents and in the ocean, are dominated by andesites and their intrusive equivalent, diorite. Finally, what happens when two continents collide? Unlike oceanic plates, continental plates are too buoyant to subduct. So when they smash into each other, they crumple and thicken, creating massive mountain ranges like the Himalayas. The intense pressure and heat deep within these collision zones cause the continental crust to melt. This process creates large volumes of felsic magma. This granitic magma is very,